It is discontinuous at that particular point. How many sums were completed so far in this exercise?
So completed question number 3, sir.
First 3 questions over. Now come to the question number 4. Prove that the function f of x is equal to x power n is continuous at x is equal to n, where n is a positive integer. This is also same as that of question number 3. Will you try this one? In the question number 3, we have taken a is a real number. Yes or no?
Yes, sir.
Similarly here, n is a positive integer. Like this, as extends to n. Okay, find out as extends to n. Limit of f of x is equal to, check that, f of n. Yes sir? All the two values equal or not, just to verify that. And you have to show that it is a continuous. Automatically both values will be equal, will be the same. Okay.
So 4 is homework, sir.
Will you try the question number 4 by yourself?
Okay, sir.
Please try it. Now come to the question number 5. Is the function f defined by f of x is equal to x if x is less than or equal to 1, f of x is equal to 5 if x is greater than 1. Continuous at x is equal to 0, at x is equal to 1, at x is equal to 2. In three different points, we had to verify, we had to check whether the given function is continuous or not. Now let us write the given function. Given f of x is equal to x if x is less than or equal to 1, that is equal f of x is equal to 5 if x is greater than 1. Now let us represent this function on the number line, at which point the function is defined in two different ways. At which point, can you identify? At which point the function is defined in two different ways?
Yes, sir.
At which point? Numerically, I am asking at which point the function
1,
is
sir.
defined.
1, sir.
Yes, 1. At this particular point 1, at this number 1, the function is defined in two different ways. Less than, left side of the number 1 and right side of the number 1. Left side of that particular number 1 and the right side of that particular number 1, the function is defined in two different ways. Now I am showing this function on the number line, especially 1. Please focus this part. At which point the function is defined in two different ways. At this 1 only, at this 1, the function is defined in two different ways. So on this number line, directly, so okay, 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4. So at this point 1, it is defined in two different ways. So I'm dividing this number line into two parts, into two intervals. Minus infinity to 1. Please remember these points, Madison. These points will help you in the next chapters. So please remember, please listen these points very carefully. Here I divided the number line into two different intervals. That is, first interval is minus infinity to 1 and the second interval is 1 to infinity. I divided this number line into two different intervals, minus infinity to 1 and the second interval is 1 to infinity. In this interval, minus infinity to 1, f of x is defined as, how the function f of x is defined, tell me? X is less than 1. Minus infinity to 1 means x is less than 1. We are taking the values for x less than 1. See here, all these numbers less than 1 or not? All these numbers on this number line less than the number 1 or not?
Less than the number 1, sir.
Less than 1. All these numbers on this number line greater than 1 or not?
Yes, sir.
So, if x is less than 1, if x is less than 1, what is f of x? Tell me, what is f of x? What is f of x? Observe this given data. Observe the given data carefully.
X, sir.
What is f of x? If x is less than 1.
Sorry, X, sir.
X only. F of x is equal to x. If x is equal to 1, f of x is equal to x. At x is equal to 1. Okay. At x is equal to 1 also, f of x is defined as f of x is equal to x. If x is greater than 1, what is f of x?
5, sir.
Yes, f of x is equal to 5. F of x is equal to 5. So, see these 3 parts. Now, we have to verify the continuity of this function at x is equal to 0. Points. Points verified at x is equal to 0, at x is equal to 1, and at x is equal to 2. These 3 points are given. At these 3 points, whether this given function is continuous function or not. Okay, now let us verify at this particular point. Points wise, we are verifying points wise. At this particular point, the function is continuous or not. So let us verify. To verify the continuity of f at x is equal to 0. At x is equal to 0, we are verifying that whether the given function is continuous or not. Okay. Now, but see this point. At this point 0, f is defined in 2 different ways. Is the function defined in 2 different ways at this point 0? At this point 0, see here. At this point 0, is the function defined in 2 different ways?
No, sir.
No, sir.
It is not defined in 2 different ways at this particular point 0. I'm asking here, at this point 0, it is not defined in 2 different ways. Only at x is equal to 1, f of x is defined in 2 different ways. Not at any real number, only at x is equal to 1. The function is defined in 2 different ways. So here, at this point, x is equal to 0, no need to find the left hand limit and right hand limit. No need to find left hand limit and right hand limit, because at x is equal to 0, the function is not defined in 2 different ways. Please remember these points, my children. Understand these points carefully. At this one only, the function is defined. Left side differently and right side differently, it is defined. But at x is equal to 1, at x is equal to 0, the function is not defined in 2 different ways. So in that case, no need to find left hand limit and right hand limit. So finally we get as x tends to 0, limit f of x. Let us find as x tends to 0, limit f of x directly. Now find as x tends to 0, limit in this interval 0. In which interval? In this interval only, the point 0 is there. Then what is f of x here? in this interval, what is f of x?
X, sir.
X only. Because 0 belongs to minus infinity comma 1 in this interval only. This number lies in this interval only. That is why we have taken f of x is equal to x. Now, what is the limit of this function? Tell me. What is the limit of this function? What is the limit of this function?
0, sir.
0. Previously, I told you, first and foremost method is direct substitution method. So we substituted x is equal to 0 in this function. We got here limit of this function at x is equal to 0. Now let us find f of 0. F of 0. What is f of 0 in this function only? Not this one. I have to take this function only. What is f of 0?
0, sir.
0 only. Are these two values equal or not?
Yes, sir.
As x tends to 0, limit f of x is equal to f of 0. Therefore, f is continuous. F is continuous at x is equal to 0. So we have verified that the function is continuous at this point 0. Again, two more points are left. At x is equal to 1 and at x is equal to 2, we have to verify. Okay, my children. Understood this point?
Yes, sir.
Now, take the screenshot of this page number 1. If any doubt is there, message me. If any doubt is there at any step, please message me in the chat box. Ask your doubts and get your doubts clarified. Have you taken the screenshot of this page number 1? My dear children, have you taken?
Yes, sir.
Yes. Now come to the next point. That is, what is the next point here? What is the next point to verify?
Sir, at x is equal to 1.
Yes. To verify the continuity of this function at x is equal to 1. At x is equal to 1. At x is equal to 1. Is this function defined differently in two different ways at x is equal to 1? At x
Yes.
is equal to 1. Is the
No,
function
sir.
defined in two different ways?
No, sir.
At x is equal to 1, left side one way and
Yes, sir.
that only I am asking. At x is equal to 1 means not exact at x is equal to 1. Left side we have to check and right side. At this particular point, left side and right side. Whether
Okay,
the
sir.
function is defined differently.
Okay, sir.
Defined or not?
Yes, sir.
Defined. See here, at x is equal to 1, left side and right side. It is defined in two different ways. In this case, we have to find left hand limit and right hand limit. You have to observe carefully where we are finding left hand limit and right hand limit. At which point we are not finding left hand limit and right hand limit. Directly we are finding limit of the function at that particular point. In this case, we should find left hand limit and right hand limit because at this point 1, left side f is defined differently and right side f is defined differently. That is why we are finding left hand limit and right hand limit. So, Just I am writing in short form. LHL stands for left hand limit. Similarly, RHL of F at x is equal to 1. And we have to find f of 1. We have to find all these three values separately. All these three values separately. If these three values are equal, then we say that f is continuous at x is equal to 1. Otherwise, it is not continuous. So, how do you find left hand limit as x tends to 1 minus limit f of x is equal to. Remember this notation, my dear. This notation stands for left hand limit of f of x at x is equal to 1. So as x tends to 1, x tends to left hand limit means left side. You have to take the left side function. What is f of x? Left side 1. What is f of x?
X.
X, sir.
X.
Because 1 belongs to minus infinity comma 1. Less than 1 means x less than 1 means x belongs to this interval only. X belongs to minus infinity comma 1. Then find the limit of this function. What is the limit of this function? Tell me.
1, sir.
1 only. Substitute the value of x in the given function. That is only repeatedly writing that sentence. Direct substitution method. I'm writing that sentence also clearly, not only orally telling this point. I'm writing that sentence also clearly by direct substitution method. You are not catching the point. By using this direct substitution method, we found limit of this function. Now come to this right hand limit. As x tends to 1 plus limit f of x means right side 1. X tends to 1 plus means right side of that point number 1. So as x tends to 1, here no need to write 1 plus. Here also no need to write 1 minus. Because we decided what is the function in this interval. What is the function in this interval? Now tell me 1 plus. If x is greater than 1, what is f of x? Tell me.
5, sir.
Huh? What is f of x?
5, sir.
5.
Five.
Because x belongs to 1 comma infinity. In this interval only we are taking in this interval. So what is the limit of this function? Tell me. What is the limit of this function?
5, sir.
5 only. If x is 1, then we substitute x value 1 in this function. X is not there, the same constant only. This is the right hand limit of this function at x is equal to 1. Now let us find f of 1. Means at x is equal at x is equal to 1. If x is equal to 1, what is f of x here? I wrote here, tell me. In this function, particularly at this x is equal to 1, what is f of x here? F of x is equal to x. So
X, sir.
Function, f of 1. F of 1 is equal to 1 because f of x is equal to x. If x is equal to 1, if x is equal to 1, the function f is defined like this. F of x is equal to x only. Now tell me, what is left hand limit?
1, sir.
What is right hand limit?
5, sir.
5. Here, what is the function value at x is equal to 1?
1, sir.
So, are these three values equal?
No, sir.
No. So, here, these three values are not equal. Therefore, we say that the function is not continuous at x is equal to 1. Actually, by seeing these two values, we can say that as x tends to 1, limit f of x does not exist. Since the limit does not exist, no need to find this part also. No need to go to the third step. This is the first step. This is the second step. That this is the third step. If in these two steps, if we get the same values, then we go to the third step, whether we are getting the same value or not. Okay. So finally, you write this point here. As x tends to 1 minus limit f of x is not equal to as x tends to 1 plus limit f of x. This implies as x tends to 1, limit f of x does not exist. Does not exist. Therefore, f is not continuous at x is equal to 1. After this box, write this part. When you are preparing your classwork notes, when you are writing your classwork notes, after this table, write these 4 lines. Okay, understood this part? At x is equal to 1, whether a function is continuous or not.
Yes, sir.
Okay, now take the screenshot of this page number 2. Take the screenshot of this page number 2. But when you are writing the classwork notes, write it properly. Write the classwork notes properly. Just you are taking screenshots. Don't write as it is. Don't write this one as it is. Completed the screenshot of this page number 2.
Yes, sir.
Yes, sir.
Now, what is the next point? Tell me, what is the next point?
Sir, we need to verify at x is equal to 2.
Very good. We have to verify the continuity of the function. We have to verify the continuity of the function at x is equal to 2. At x is equal to 2. Now come to this point number 2. On this number line, please observe this figure. Just by observing this figure carefully, you can easily identify whether the given function is defined, in 2 different ways at that number 2 or not. At x is equal to 2 means at the number 2 on the number line, whether the function is defined in 2 different ways or not. Tell me.
No, sir.
It is not defined. See here, number 2, at number 2, it is not defined in 2 different ways. Only at x is equal to 1. I repeated the point previously. At only x is equal to 1, the function is defined differently, left side and right side of 1. But at x is equal to 0, but at x is equal to 2, function is not defined differently. Now, in this case, also, no need to find left hand limit and right hand limit. Directly, we find limit of the function. No need to find these two steps. No need to find these 2 steps. So directly we find limit of this function at x is equal to 2. So as x tends to 2, limit f of x. So as x tends to 2, limit, tell me what is f of x? In which interval number 2 is there? In which interval number 2 is there?
Sir, 1 to infinity, sir.
1 to infinity. Then what is f of x? Tell me.
5, sir.
What is f of x?
5, sir.
5 only, 5. Because 2 belongs to 1 comma infinity. This number 2 belongs to this interval only. This number belongs to this interval only. So what is the limit of this function?
5, sir.
5. Now let us find f of 2. f of 2. What is
5,
function
sir.
here? 5 only. This function only. We have to take this function only. So 5. Are these two values equal or not?
Equal, sir.
Yes, equal. Therefore, as x tends to 2, limit f of x is equal to f of 2. Therefore, f is continuous at x is equal to 2. Is this point clear?
Yes, sir.
Yes. Now take the screenshot of this page number 3. Take the screenshot of this page number 3. If any doubt is there, message me in the chat box. Otherwise, take the screenshot of this page number 3. Have you taken a screenshot of this page number 3?
Yes, sir.
Now come to the question number 4, 5, or 6. Find all the points of discontinuity of f where f is defined. Where f is defined. We have to find the discontinuity, points of discontinuity. Points of discontinuity. Yes, come to the question number 6. Find the points of discontinuity of f where f of x is equal to 2x plus 3, 2x plus 3, comma, if x is less than or equal to 2. F of x is equal to 2x minus 3 if x is greater than 2. Please observe this function carefully, my children. At which point the function is defined differently? At which point the
2,
function
sir.
is defined? At number 2. Yes or no? At number 2. We have to verify the continuity of this function at this point only. At this point only. If it is continuous at this particular point, then we say that it is a continuous function. Otherwise, this point, at this point, it is a discontinuous. That's all. This is a hint for us. This part is a hint for us to check the continuity of a function at which we have to verify. Understood this point, very children? Now, I represent this data on the number line. I will show the data pictorially. At which point the function is defined differently? At which point the function is defined differently? Kevin Paul, Grayson, Yashwant Ram, Power
2, sir.
Science.
2, sir.
Two. So, after finding the point, after identifying the point at which The function is defined differently. Divide the number line. Divide the number line like this. By a vertical line, divide that number line. Then you got two intervals. Can you tell me what are the intervals? Can you tell me this interval? Can you tell me this interval?
Sir, minus infinity to sir.
Yes, minus infinity comma 2. And what is this interval?
2 to infinity, sir.
Yes, or open interval 2 comma infinity. Now let us write the functions in this interval. What is f of x? In this interval, what is f of x? So what is f of x in this interval? Tell me. What is f of x in this interval? In this interval means what is meant by this interval? X values are less than 2.
Sir, 2x plus
1 is
3.
less than 2, 0 is less than 2, minus 1 is also less than 2. All these numbers are less than number 2. Yes or no? Then what is f of x? Tell me. What is f of x?
2x plus 3, sir.
Yes, 2x plus 3. This one. X is less than or equal to. If x is greater than 2, what is f of x?
2x minus 2, sir.
Yes, f of x is equal to 2x minus 3. Especially at this particular point, what is f of x? If x is equal to 2, what is f of x? Tell me. Particularly at x is equal to 2, what is f of x? See here, less than
2x
or
plus 3,
equal
sir.
to. Less than or equal to means x values is also 2. So in this case, f of x is equal to 2x plus 3. See here, these three functions are important for us to verify, to check the continuity of this function. Okay, so it is enough to check, to verify the discontinuity, points of discontinuity, to find the points of discontinuity. So to verify the continuity of f at x is equal to 2. How do you verify the continuity of this function at x is equal to 2? How do you find the continuity of f at x is equal to 2? Tell me. How do you find? How do you find the continuity of this function at this point number 2? How do you find? Just to revise the previous
Sir,
question.
equate LHS, RHS and on that.
Not LHS. Don't say LHS. LHL.
Okay, sir.
LHL, left hand limit.
Okay, sir.
LHL stands for left hand limit, or HL stands for right hand limit. So LHL of f at x is equal to 2. Next, or HL of f at x is equal to 2. And finally f of 2. We have to overcome, we have to pass all these three levels. If you pass, if the function satisfies all these three levels, then it is said to be a continuous function. Otherwise, it is discontinuous at this point. So it is this point is said to be point of discontinuity. At this point, function is discontinuous. In that case, we say that number two is said to be point of discontinuity. Okay. Now let us find left hand limit extends to 2 minus limit f of x is equal to, and extends to 2 limit. What is f of x in this interval? In this interval, what is f of x?
2x plus 3, sir.
Yes, 2x plus 3. Because 2 belongs to or x belongs to e minus infinity comma 2. Then what is the limit of this function? Tell me. What is the limit of this function? How do you find?
Substitution, sir.
Direct substitution. Tell me what is the 2 into 2 plus 3 by substitution, by direct substitution, by direct substitution method. So what will you get here? 4 plus 3. So this is a left hand limit of this function at x is equal to 2. Similarly, we find RHL, right hand limit of f at x is equal to 2. So we denote it by as x tends to 2 plus f of x. That is equal to as x tends to 2. Tell me what is the function in this interval? What is f of
2x
x?
minus 3, sir.
2x?
Minus 3, sir.
Yes, 2x minus 3 because x belongs to 2 comma infinity. In this interval only, we are taking the values of x in this interval only. How do you find? 4 minus 3, that is 1. After completing these two levels, after completing these two steps, we have to verify. No need to go to the next level. No need to take the third step. Just observe these two steps. Are we getting the same value or not?
No, sir.
So, no need to go to the next level. No need to check that third step. We can stop this part. No need to check this one. So, finally we write here as x tends to 2 minus limit f of x is not equal to as x tends to 2 plus limit f of x. Left hand limit and right hand limit both are not equal. In that case, we say that limit does not exist. So as x tends to 2, limit f of x does not exist. Does not exist. Therefore, f is not continuous. F is not continuous at x is equal to 2. Therefore, 2 is the point of, this is the actual point. What is they asked here? We have to conclude the answer by that point only. So 2 is the point of discontinuity. This is our conclusion. We have found, we have verified whether this function is continuous or not at this particular point too, because function is defined in two different ways at that particular point too. That is why we found. Understood this point, my children?
Yes, sir.
Now take the screenshot of this page number 4. Take the screenshot of this page number 4. Make it fast. Take it fast.
Done, sir.
Yes, if there is any doubt, my dear children, please ask your doubts and get your doubts clarified. Feel free to ask your doubts and get your doubts clarified. Okay. Yes, now the time is 12 past 29 minutes. 12 past 29 minutes. Now, will you try the question number 10? Question number 10. Question number 10.
Okay, sir.
I will explain you in the next class. I will explain you 7th, 8th and 9th. All these three are of the same type. I will explain you later in the next class. You will try question number 10, 11, 12 and 13. 10, 11, 12 and 13. Will you try these questions?
Okay, sir.
Similarly, you can do this one also. 14, 16, 15, 14. All these questions are of the same type. Up to 16 questions. Okay. Please try these questions. Do these questions as homework. If you have any doubts in the homework sums, please feel free to ask your doubts and get your doubts clarified. 10,
Sir,
11,
fourth one is also the homework, no, sir?
Huh?
Fourth question is also the homework, no, sir?
Yes, fourth question is a fourth question also. Fourth question also. Four, 10, 11, 12, 13, 14, 15, and 16. All these questions are of the same type. Before doing the homework sums, please refer the classwork notes. Question number 1 to 6. Which procedure is applicable to the question? Please apply that procedure and find the solution. Okay. Now you can leave the
Okay,
meeting, my children. Now the time is
Thank you, sir.
31 minutes. You can leave the meeting. Take rest. Take care of your health, my children. Stay at home.
Thank you, sir.
Stay safe and sanitize your hands. Frequently maintain social distance of 2 meters away from others and do your duty sincerely and seriously. And thank you all. Thank you all.
Thank you, sir.
Thank you, sir.
Thank you.
Gurisan. Thank you, my dear Ayush and Joseph.